Hi, today we're going to be looking at a Racal-Dana 1992. That's the model number down there. And it's a frequency counter that will measure up to 1.3 gigs on the C input there. Every now and again these need calibrating, and this has been calibrated a while back, but it's time to check it. So I'm going to compare it to my GPS disciplined oscillator that I have over here, and what that does, it picks up signals from the GPS satellites and adjusts the 10 meg reference oscillator inside to match the GPS signals that it's receiving from space. So what I'm doing right now, I'm feeding in, or will be feeding in, the 10 meg reference off the back of the GPS disciplined oscillator and feeding it into the input on the front of the frequency counter, and what we should see is a 10 meg signal once everything's warmed up, because everything's going to take a while to come up to temperature, because this has an internal ovenized 10 meg oscillator which could take, you know, a good half an hour to warm up, or more even, to be really accurate. And then the GPS oscillator here, the GPS disciplined oscillator, also will take a little while to warm up. So there'll be some pauses in the video, you know, while these things are warming up, and then we can see how accurate this is compared to the GPSDO that I have over there. So here we go. Let's actually, yeah, I'll turn this on first. So that's the frequency counter powered up, and next will be the GPS oscillator. So that's going to be picking up GPS and GLONASS, the Russian satellites, as well as the American satellites. Right now it doesn't have a fix on any satellites, so give it a couple of seconds and hopefully that will be locked on to a number of satellites, and it will have somewhere near a 10 meg frequency. Right now it's going to be approximately 10 meg, but actually, oh, there we go. So we have a signal, but it's not accurate yet, so we've got to give that a chance to warm up a bit. And then over here we're looking at the frequency counter, and you can see that right now we're not anywhere near an accurate 10 meg signal there. We're quite a ways off. So we've got, there's hertz there, so we're about 450 hertz out right now, but this is still warming up and it's going to take a while to warm up. And the disciplined oscillator over here is still warming up, and that's going to be coming up to its correct frequency very shortly as it corrects its frequency, internal frequency. So right now we're monitoring the GPSDO, and it's about 4 hertz high at the moment, and that should settle down to be a very accurate 10 meg very shortly. And you can see here we're still quite a ways off, so we're about 370 hertz out at the moment, and it's still climbing, so this is going to take a while to come up to frequency. on the back of the frequency counter here, we've got a 10 meg output. So this will be the internal 10 meg clock that is the ovenized 10 meg oscillator. So what I'm going to do is compare this waveform and the waveform that's coming off the GPSDO on my scope, and put the scope into a mode where we can compare the two waveforms. So I'm going to connect the 10 meg here from the back of the GPSDO onto the front of the scope here, and we should see a nice 10 meg oscillator output. That's a nice sine wave. I don't take much notice of this frequency up here. The scope's never going to give you an accurate frequency measurement. It's not designed for frequency measurement. Down here you can see it's saying it's approximately 10 meg. But scopes are not really designed as frequency counters, but they're going to give you an approximate frequency. Alright, so that's the sine wave from the GPSDO, and we take the other input and we're going to connect it to the back of the frequency counter here and measure or do a comparison actually of the two. So we're going to compare this one, connect the scope up to there, and you can see we're triggering off the GPSDO, and let me change the amplitude a little bit on these. Okay, so we're triggering off the top waveform, which is the GPSDO disciplined oscillator. This is the output, 10 meg output from the frequency counter. So you can see they're not anywhere near close at the moment. So that's going to take quite a while to settle down. But eventually, this one here is going to look frequency-wise almost identical to this one, if everything works according to plan. Now, I know there's going to be a difference, but hopefully it's just a slight difference, which eventually we should be able to adjust so that it's a lot more accurate and a lot closer to the GPSDO frequency. And that's going to take a while to settle down. So let's go back to looking at the front of the frequency counter and see how it compares. You can see here we're now about 70 hertz out, if my math's correct. So there's megs. Yeah, this would be the hertz. So right now we're about 60 hertz out, and it's getting more accurate as it gets warmer. That oven is still, the oven inside this, the ovenized oscillator, is still getting hot, still warming up, so we've got a while to wait before that gets up to temperature, and then it will hopefully be a lot closer to 10 meg. So the GPSDO is now settling down at 10 megs with just a few millihertz out, so it's about 8 millihertz high at the moment, but it's a pretty accurate 10 meg right now. And it's getting there slowly. This is settling down now. That's my reference. And okay, so now we're a lot closer. We're getting there. I could increase the resolution actually and go up another digit on the resolution. Sorry about the lighting, it's not very well lit in here at the moment. So now we've got, this is our 1 Hertz digit here, a single Hertz digit. So I wouldn't be surprised if this overshoots with the oven temperature and goes above 10 meg and then settles back down to 10 meg or thereabouts. It should be pretty close. I haven't messed with it since it was calibrated, so I didn't have the GPSDO to calibrate this myself. Okay, so now it's just gone a little bit high of the 10 meg. If we come down in resolution, you can see we're now just a little bit high, but that's only 600 millihertz, 800 millihertz out right now. That's a single hertz. That would be the 1 Hertz digit or single Hertz digit. So we're about 1.1 Hertz out on the frequency measurement right now. Now the GPSDO has dropped a little bit in frequency, so it's this is still correcting its measurement, and in a little while that should settle down to a more accurate reading. It's still pretty close, and we are very close with this too. So what I'm going to do, I'm going to hook the two back up again onto the scope, because I disconnected the 10 meg from the GPSDO to actually measure the frequency here. So now I'm going to connect the two back into the scope and we can compare the waveforms on the scope. So now we can see here that the top waveform is the GPSDO output, 10 meg output from that, and then the bottom waveform is the 10 meg ovenized oscillator in the frequency counter. So there's still a bit of a difference between the two, but they're a lot closer than they were. So let's just leave it a bit longer and see how we go. And I'd like to see those two synchronize, but if they don't synchronize after a good hour, then I could adjust the bottom waveform so that it synchronizes with the top waveform, or at least as close as possible. And that would be by adjusting the internal oscillator on the frequency counter, which is down here, which is on the back here. So there's a fine and coarse frequency adjustment, and I've not, well, it's you can see the piece missing off the back of this seal, but this hasn't been adjusted. So this is where I could adjust the internal oscillator on the frequency counter, and there's two positions. There's a coarse and a fine underneath a couple of screws here, so I'd have to break the seal, and then once I broke the seal, take the screws out to get at the adjustment and adjust that with a ceramic screwdriver. So there's the ceramic tool. You can't use a metallic tool because that's going to upset the capacitance that you're adjusting, so or inductance even that you're adjusting. So yeah, that's the ceramic tool. When I bring the screwdriver away, I don't want it to mess with the adjustment of the oscillator. And why are we not focusing? Okay, that's better. Yeah, so that's where I would adjust it if necessary, underneath this seal here. And let's go back to looking at the scope. So yeah, getting pretty close. Still Still just a little bit out. If you can hear that noise, it's the fan in the oscilloscope. If you can hear that rushing noise. So this is where we are now. So what are we? So we're now down to 0.3, 0.4 of a hertz out, and the GPSDO is pretty much exactly 10 meg now. So it looks like we're about 0.3 of a hertz out, which which is not bad considering this hasn't been touched in quite a while for calibration. So I'm going to leave this running for a while and see if it settles down any closer to that. It's getting really close. 0.3, 0.2 of a hertz difference. So that's pretty good going. So you can see now how close we are with the two oscillators, getting very close. Another thing people like to do with comparing frequencies like this is looking at the comparison with the XY plot on the oscilloscope. So you're looking at the Lissajous pattern, and ideally it should be excuse me, ideally it should be a circle which is stationary, and right now that's going to be really close. So let's do an XY plot and see how that looks. Okay, so we're looking somewhere near. I've got to reposition that a little bit. Yeah, it's a digital scope, so it's not going to be as nice a display as on an analog scope, and I should probably be using an analog scope for this, but you can see that that's almost identical frequency, almost identical. Let me increase the reference on this. So that's almost stationary. So those two frequencies now are going to be almost identical, if not identical. So let's go back to the regular waveforms. Yeah, you can see now they're pretty much locked together. There's just a slight variance with the bottom waveform. And let's go back to looking at the frequency counter display. Well, you can't get much closer than that. That's pretty damn close. I don't think I need to do anything with that frequency counter. It's pretty much spot on. So I'm not even going to adjust that. I don't think there's any point. The GPSDO is exactly 10 meg. That's showing me exactly 10 meg as far as its resolution. And I don't know whether I can increase the resolution a shade. There we go. So we're now, what are we? We're 0.04 hertz out. I don't think I'm going to even bother adjusting that. There's no point. It's close enough. If I come down in resolution, oh, wrong way. Yeah, there we go. So I don't think there's any point adjusting that. I don't think it's going to be any closer, even if I try adjusting it. So that's just confirmed the calibration of the frequency counter. It's good. It's a good accurate frequency counter. A lot of people like these frequency counters. And this one's nice because it does have the ovenized oscillator in it, which means it's going to be pretty accurate. But and not only that, I could feed the 10 meg GPSDO 10 meg reference into the back of this and use that as an external clock, so that I can do frequency measurements with this being controlled by the GPSDO reference. But right now it's pretty damn close. I don't think I'm going to bother adjusting that. It's close enough. And if we go back to the oscilloscope, the top one again is the 10 meg off the GPSDO 10 meg out, and the bottom one is the 10 meg from the frequency counter's ovenized oscillator. And yeah, there's a slight difference there, but it's really not worth worrying about. What I'll do, I'll just leave these on now, and so it gives them a chance to really warm up. You know, to do any calibration on these, you should probably leave them running for 24 hours to give them a chance to really settle down. But I don't think I need to worry about the accuracy of that frequency counter. It's pretty much bang on. And coming back to the frequency counter, like I said, that's pretty much bang on. I don't think I'm going to even adjust it. I think it's close enough. So anyway, thanks for watching. If you enjoyed the video, give me a thumbs up and subscribe for more videos. Thanks again. Bye for now.